Few of the point I would like to revise it again. Uh, Unit impulse signal is basically, as I have discussed in the previous lecture, is a rectangular pulse of zero width. This is a rectangular pulse, but its width will be 0. And at t equal to 0, its amplitude will be tending toward infinity. Or in previous lecture, I have discussed about, already I have discussed about its mathematical representation. So you must go through that video in which I have discussed that uh, a unit impulse signal has zero magnitude everywhere or for any value of t, and it is undefined when t equal to 0. Means amplitude of the unit impulse signal cannot be defined at t equal to 0. I have discussed this in previous video. So you should go through that video. And the second thing which is required to derive its property is the area of unit impulse signal. Area under the unit impulse signal. If you will determine the area of unit impulse signal from minus infinity to plus infinity, you will get 1. So basically these two characteristics of unit impulse signal is often required to discuss its various property. In previous lecture, I have already discussed about its shifting property. Now I will discuss about its scaling property. What is the scaling property? Uh, Scaling property, according to scaling property, the magnitude of delta AT can be given as 1 by magnitude of A into delta T. It means the value of delta 2T will be equal to 1 by 2 into delta T according to the magnitude, according to the scaling property. Now you can prove this property just by considering the expression. Let us consider this expression. I have derived this expression, this property in this PDF file. Let us consider this expression. To derive this property, first I have considered the integration minus infinity to plus infinity delta AT xt dt. Delta AT xt dt. And here I have assumed A is greater than 0. What will you get? Dt. What will be the value of this integration? When you will calculate, when you will substitute at equal to u, then dt will be du by A. And when t will be minus infinity, then at will also be minus infinity. And when t will be plus infinity, at will also be u will be also per plus infinity. So this limit will remain same when you will substitute at equal to u. So this integration in terms of u will be converted in this form, minus infinity to plus infinity. And this at will be u, so this become delta u. And xt, This t now can be written as u by a. U by a. From here you can get the value of t. And this dt will be du by a. Since a is constant, so you can keep this a outside the integral. So now this integration in terms of u can be written as this. Now, from the shifting property, which I have discussed in the previous lecture, uh, or you can directly write answer for this integration by using shifting property. This will be equal to uh, x naught by a. This will be equal to x naught by a. Or in place of x naught, you can write minus infinity to plus infinity xt delta t dt. This is shifting property. In previous lecture, I have shown you, I have justified this statement. I have proved this statement that the integration from minus infinity to plus infinity xt delta t will be equal to x naught. So you go through that video of shifting property. So by the shifting property, you can write this as this. And when you will compare left hand side, which is started from this expression delta at xt dt. When you will compare the starting expression and this final expression, you will get this delta t become equal to delta t by a. Delta at will be equal to 1 by a into delta t, just by comparison of this initial and final expression. You will get this result. Similarly, if you will consider a as negative, then what will happen? When a will be negative, then here you have to write delta minus at. So this integral will be, let us consider this integral delta minus at into xt dt. Now I am going to derive this integration. I am going to evaluate this integration. This is the initial expression. And now I am going to substitute minus at equal to u. Then dt will be minus du by a. And when t will be minus infinity, then u will be plus infinity. So its lower limit will be plus infinity. You must note it. And when t is plus infinity, then u will be minus infinity. So first, in terms of u, the limit of integration will change, and this will be, this minus ut will be, minus at will be u and x. And from this, you can derive the value, you can determine the value of t, which will be minus u by a. And this dt will be minus du by a. Since a is constant, so you can keep it outside the integral. And when you will change upper and or exchange the position of upper and lower limit, this minus sign will become plus according to the property of integration. So this will again minus infinity to plus infinity, but this sign will change. This sign minus will become plus. And delta u x minus u by a du. And again from the shifting property, you can write this integral value by the use of shifting property, you can write this as equal to 1 by a minus infinity to plus infinity du delta u x minus u by a du will be equal to x naught again from the shifting property, and x naught you can write again from the shifting property minus infinity to plus infinity delta t xt dt. So shifting property is very important to derive this scaling property. So you must go through that video. And this is the initial expression. Initial expression was minus infinity to plus infinity delta minus at xt dt. When you will compare left hand side and right hand side, you will get delta minus at will also be equal to 1 by a delta t. So whether sign of a is plus or minus, it does not matter. Delta at will always be equal to 1 by a or mod of a, you can say, because here a is always positive, so it is better to take mod of a delta t. This property is called shifting property. Sorry, scaling property. For example, I am asking you, what is the value of delta t? Here 1, a is 1, so it will be 1 by mod of 1. So 1 by 1 it will be 1. So you will get equal to delta t. And if I ask you, what is the value of delta minus t? Here a is minus 1. So 1 by mod of minus 1. You will get this result from the use of scaling property. And mod of minus 1 will be 1. 1 by 1 again will be delta t. So you can see here both delta t and delta minus t are equal to each other, and this is the property of even signal. So you can say your impulse signal is even signal. So in this way you can derive scaling property. So in PDF file it is derived, and this PDF file is already uh, you have all this PDF file already. You have this PDF file. So go through this PDF file and try to understand its derivation and why it is a even signal. Just go through it. The second property is sampling property. It is very important property. According to sampling property, the product of any test signal with delta t will be equal to x naught delta t. Because you know, for any value of t, delta t will be 0. So this product will be 0 everywhere except at t equal to 0, where its magnitude is not defined. So this product can be replaced by this product, because except t equal to 0 everywhere, this product will be 0. So this product can be written in terms of x naught and delta t. So this is sampling property. Similarly, uh, consider this expression. From this expression, it is clear. Except t equal to t naught. Except t equal to t naught. Delta t minus t naught will be 0 everywhere. So this product will be 0. And at t equal to t naught, delta t minus t naught cannot be defined. So you need to calculate this product only at t equal to t naught. Except t equal to t naught, there is no need to determine this product, because it will be 0. Because delta t minus t naught will be 0 everywhere. So this product can be written as xt naught delta t minus t naught. So these two expression represent the sampling property of impulse signal. Similarly, differential property, this is differential property. You can easily derive this differential property by using the method which is suggested here, or this is in previous lecture I have discussed you that if the integration of the product of generalized signal with any test signal dt. In previous lecture I have already discussed this integration, that the product of the differential of generalized function with any test signal will be equal to minus of this differential will shift to the test signal. This will be equal to gt x differential t into dt from minus infinity to plus infinity. So you can use this property, and this property you can derive from the uh, property of integration. So it will be easy. You can derive it. So by that property, by this property, this differential sign is shifted here. Delta t. Now xt delta dash t become equal to x dash t delta t by the use of this property. But minus sign will be here. And now, as you know, this delta t is 0 everywhere except t equal to 0. And at t equal to 0 and t equal to 0, delta t is not defined. So, by the use of shifting property, you can write directly this integration will be equal to x not 0, because everywhere uh, delta t will be 0. For your understanding, I am going to derive this property. Let us see. This is the differential property. Xt delta dash t. You have to show xt delta dash t. Delta dash t means differential of impulse signal dt minus infinity to plus infinity. You have to find the value of this integration. First, by the use of the property of integration, you can write this integration as this differential sign will be on x dash t. You just go through the previous video for this property. Delta t dt. You can write this as this. Now, from the fundamental concept of impulse signal, this delta t will be 0 everywhere. Everywhere it will be 0. Only you cannot uh, evaluate, you cannot determine its magnitude at t equal to 0. So everywhere this product will be 0 except at t equal to 0. So the by use of the same sampling property which I have discussed here, this is the sampling property. This product can be written as minus of x dash naught delta t. I am using sampling property here. Or from the fundamental concept, you can say, since this product is 0 everywhere, because delta t is 0 everywhere, so the meaning of this product is you have to calculate this product only at t equal to 0. Otherwise, its value is obvious. Otherwise, if t is not equal to 0, then it is obvious this product will be 0. So you are going to evaluate this product. It means you are going to evaluate this product only at t equal to 0. Because except t equal to 0, everywhere this product value is already known and it will be equal to 0. So you can replace this product as this. Now this is a constant. So you can keep this value outside the integration. outside the integration, and delta t dt. And from the fundamental knowledge of the impulse signal, you know this is the area under the impulse signal which is equal to 1. So you can write it as minus x dash 0 into 1 which is equal to this. In this way, you can derive this differential property. So this is very easy. So you must go through the PDF file which I have already given to you all, and also watch all the video which I have uploaded, and I hope you will understand it clearly. So this is about the differential property. In the same way, here is amplitude reversal, and I have already derived its expression. So you go through, you have to remember, when you will multiply delta differential of impulse signal with t, then you will get negative value of this. So this integration, proof of this expression is also very easy. You can easily understand through, uh, you can easily understand this integration. So just you have to go through this PDF file, and you can understand it. So in conclusion, the property which I have discussed for the impulse signal is, first, the area under the impulse signal will be equal to 1. These are the property of impulse signal. This is shifting property. Shifting property, you must remember, you are going to calculate the sum of this product from minus infinity to plus infinity. And you can easily understand the sampling property and shifting property. What is the meaning of this product? Already you know the value of this product for all the value of t. If I'm asking you determine this product, you can easily say, sir, this product will be 0 everywhere except at t equal to 0. This product will be 0 everywhere. Its value is known already to you all, because delta t is 0 everywhere except t equal to 0. So the basic thing about this product is, this is basically a product at t equal to 0. Because only at t equal to 0, you do not know the value of delta t. So the calculation of this product means the calculation of this product. And this is the basic of sampling property and shifting property. So shifting property, which I have discussed in the previous lecture, is very simple. Just you have to understand the meaning of this product. This product means you want to calculate the integration of this product only at t equal to 0. Because other than t equal to 0, already you know that this product will be 0. Because delta t is 0 everywhere except t equal to 0. So this product indicate you are going to calculate the integration of this product only at t equal to 0. So first you will replace this product in its real form. This is the real thing which you want. And since this one is constant, and when you will keep this expression outside the integration, then the remaining integral is nothing, but it is just a area under the impulse signal. And from the property of impulse signal, you already you already know this integral will have unit magnitude. So you will get 1. So x naught into 1, you will get 1. This is the shifting property. In shifting property, you are using sampling property. Replacement of this product by this product is sampling property. And this one is the shifting property. Similarly, by the use of sampling, uh, property, you can write this product as xt naught delta t minus t naught. And again delta t minus t naught from t1 to t2 will be the area under delta t minus t naught, and it will be equal to 1. You will get xt naught. So these two are the shifting property which I have discussed in the previous video. This is a scaling property which I have discussed today in this lecture. And these two are the sampling property. This is the differential property, and this is the amplitude reversal. So you must remember all of this property of impulse function, and with the use of these property you can not only analyze the various type of signal, but you will solve various types of mathematical expression also. So these property are very important, and in the examination uh, the question may be asked, prove scaling property, prove uh, shifting property. This type of question may be asked in the examination also. So you must go through all the property which I have discussed uh, about the uh, impulse signal or impulse function. So you should go through this PDF file to know about all the property of uh, sampling theorem. So in this way, the one part of this unit is finished, which is signal. In next lecture, I will discuss about the system. What is the system? What is the meaning of linear system, non-linear system? What is time invariant system? What is time variant system? So I will upload the video on that type, that contents also. So first, you will have to go through the basic concept of signals.